Ta-da! How's it going? It's been a while, right? Has it been a while? How long's it been? How are you guys doing? My neck really hurts. I don't know what's happened. I injured my neck somehow. I've ordered some Tiger Balm off the internet, so I'm going to smear that all over my neck. I'm going to smell awful for a while, but then hopefully the neck will be fixed. Who knows? Who knows? Not dead yet. Excellent. Let's keep that up. I forbid any of you to die until you've at least got GCSE. Preferably until you've got A levels as well, because then I get to teach you some A level stuff as well. Cool. Okay. So right. In the lead up to the half-term break, we were basically doing programming practice. If you're ever in a situation where you don't have specific work set, but you have time allocated to do computer science work, what you need to be doing is programming practice, either working through my video tutorials or working through some of the puzzles on checkio.org. There are various other websites that I can point you in the direction of to help you flex your skills there, right? But we are going to start a new unit. It's going to be a fairly short unit, to be honest, but it's some stuff which is sort of, it's not the sort of thing that you need to know just on its own, but it fits in around everything else. So yeah. So the title of the full unit is Translators and Facilities of Programming Languages, which I have pasted into the Discord Serious Business channel, so you can use that. Translators and Facilities of Programming Languages. That's the one. Translators and Facilities of Programming Languages. Thank you very much, James. So let me tell you what that actually means. Basically, when you type in a computer program, you think, oh man, I've got to write in Python or C++ or C# or whatever. I've got to program this stuff in. Because the computer doesn't understand English. It only understands Python. It only understands whatever programming language I'm typing in, right? Well, actually, it doesn't even understand those. The only thing that, well, you tell me, what's the only thing a computer understands? Yeah, binary. That's right. Okay, it only understands ones and zeros. Okay, I mean, technically, it doesn't even understand machine code, right? It literally understands. It doesn't. Well, let's be real here. Computers don't understand anything. They're very good at routing electricity around. So all we're doing with a computer is we're sending little bursts of electricity. Now we make it easier for us to understand what's going on by saying that's binary, that's ones and zeros. If there's voltage, it's 1. If there's no voltage, it's 0, right? And so the combination of all those ones and zeros in binary we refer to as machine code, as George pointed out. Okay, so the whole point of this next unit is looking at what actually happens when you type in your programming language, and how does it get translated from words that you type in down to the ones and zeros that the computer can understand. What is the process that goes on there? Now, This is GCSE, so we're not going to get into all of the details. If you are interested in what actually goes on on a more specific level, that's an A-level topic, and we will write programs at A-level that actually take commands that you type in and convert them into binary. And I will show you how you can program in raw binary if you want to. So there's a thing. Anyone that is interested in that, feel free to tune into my A-level streams when I get them going. Okay, so that's basically what we're going to have a look at. We're also going to have a look at what an IDE is and what some of the features of an IDE are. Even though you guys have been using an IDE for the past year or so. Someone tell me what is the name of the IDE that we use when we write Python? PyCharm is correct. So out of interest, anyone used any other IDEs? And when I say other IDEs, I don't just mean Python IDEs. Any other IDEs other than... Now here's the thing, right? There's a couple of you saying Atom. I'm not sure whether Atom actually counts as an IDE. Same with Notepad++. They have a lot of the features of IDEs, but they're not necessarily a full IDE in themselves. So we'll and I'm not going to explain the distinction here, but we'll have a look at that. Yeah, Visual Studio. I mean that's. Microsoft has an interesting way of doing things. Let's just say. Okay, right. So I mean that gives you an idea of what we're going to have a look at over the course of the next X number of lessons. So I'm not. I mean, obviously, the stuff that I designed, I've had to sort of like reformat for online lessons and stuff like Adobe Dreamweaver. Adobe Dreamweaver is not an IDE. It's a WYSIWYG web editor. Right. I guess you could call Publisher an IDE for posters, maybe. I don't know. Anyway, so this is what we're going to look at: assemblers, compilers, and interpreters. There are 3 different methods that we can use to convert code that we write, that we understand, to machine code. That right. I'm not going down the HTML is a programming language thing. We'll be here all night. I think the static nature of HTML means that it's in a pure sense it's not a programming language. You can't it's a markup language. But then at the same time, PHP, which you can write full featured programs in, that's not a programming language either. It's a templating language. So yeah, I mean most people can't even spell HTML. So if you need to install brackets, that's a different video. Okay, right. So let's move on. For some reason, this is the first thing. The first thing here. Can you calculate the following? 3 plus 5. Do you know what 3 plus 5 is? Right. Good. Right. So well done, Josh, for actually taking this seriously. Right. I'm going to go through a series of extra stages. Yeah, go through a series of extra stages, and I don't want you to tell me the answer immediately. Okay, just keep a running total in your head or note it down on paper, and we'll see what the answer is. So here we are, 3 plus 5. We've already got an answer, 8. Okay, here we go. Next bit. Add on 10. Square it. Divide by 15. Round up. Take the first digit and divide that by 2. What answer have we got? Alex claims 1. Most people seem to say 12, which is okay. So we started off with 8, add 10, becomes 18, right? I lost track at square it. 18 times 18. 1 times 8 is 8. That's 14. 1 times 8 is 8. 1 times 1 is 1. 18 squared should be 324, I think. I can't even remember what my previous instructions were. So we squared it and then divided by 15. 324 divided by 15 was something. Anyway. I was going somewhere with this, I promise. 324 divided by 15 is 21.6 apparently. So then I said round up, which is 22, and then take the first digit and divide it by 2. The first digit was 2, and we divide it by 2, and we get 1. Okay, cool. So we went through a whole process there. I've got another maths problem for you here. Okay, so are you ready? Are you ready for this one? Are you ready for this one? Just say yes, I'm ready, or no, I'm not ready. Right. Okay. Here's this one. We've got x plus y plus 10 squared divided by z. The ceiling of that divided by 10. The floor of that divided by 2. And x is 3, and y is 5, and z is 15. Louis, straight in with 1 there. Alex guesses 6. Any other answers? One. Yeah, I mean, how did we get to 1, guys? What do you notice about this compared with the stuff that we've just done? Yeah, as George quite rightly points out, that horrible looking equation on there, it's actually the same thing that we've just done. Okay, I said to you, add 3 plus 5. So x plus y, that's 3 plus 5. The next thing that I said was add 10. So 3 plus 5 is 8. Add 10 is 18. Then I said square it. So we got 18 squared, which is 324. I then said divide that by 15. Well, z is 15, so we've got 324 divided by 15, right? Which gave us 21.6. This little thing here, ceiling, means round up. Okay, so we round up to 22, right? And now the next bit, I said take the first digit and divide by 2. Well, to take the first digit of a 2-digit number, you can divide by 10. Okay, so we divide by 10 and round down. Okay, that's what this means here. Floor means round down. And then that should give us 2, so then we divide by 2 and we get 1. It's the same thing. Okay, now there was a reason for me showing you that. Remember I said I am going somewhere with this, right? It's much easier for us to carry out lots of small problems which build to a solution than it is to look at one massive problem and try and solve that all in one go. Okay? So when you are presented with something like this, you wouldn't just sit there and say, oh God, what's the answer to that? You'd work out the bits that you can work out, okay? It's the same thing. The same thing happens when we are converting code into machine code that the computer can understand. Okay, so the computer itself actually has a fairly limited number of things that it can do. It can add, it can subtract, it can sometimes multiply, although a lot of computers don't actually do multiplication, they just do addition over and over again. Okay? So, objectives here, right? I want that little exercise, I just want you to be keeping in the back of your mind. Not just for this lesson or even this series of lessons, but all the time. Okay? That idea that if you've got a massive problem, break it down into the stages that you can understand. Okay? I'll come back to similar problems like that, and we are going to have a lesson specifically on that. It's called problem decomposition, but it feeds into this nicely because that's something similar to what the computer actually does. Okay, it only has a limited number of things that it can do, right? And so it takes the more complex things that we ask it to do, and it turns them into those simpler things so that it can complete them. So keep that in mind, and if that becomes relevant at any point during this stream, I want you to point that out to me. Okay? So it's time for that Tier 2 vocabulary. Yes, that's right. I know you like that stuff. So go online, find out the definition of the word interpreter. And I don't mean in a computing sense, I mean an interpreter in a general sense. You might already know what an interpreter is. That picture there is from the film The Interpreter. That's why it's on there. So there you go. Oh, I've got my pointer on. Yay. Okay, so what's an interpreter? George, you already know this, so remain silent. You can't use the word interpret to explain what an interpreter is. Although that second clause there translates speech orally or into sign language. Right, okay. So, yeah, if we're talking about an interpreter is that person that sits in between two different people who speak two different languages, but the interpreter understands both languages, and that interpreter translates. Okay? You get lots of interpreters working at the UN for obvious reasons. I don't know if you've ever seen people at the UN. They all have little headsets and microphones in front of them. They speak into the microphones. What everyone hears, they don't hear the things that people are saying directly. What they hear is a translation going through the interpreter. Okay, so I think that's a great definition there, Evie. Changing one form of communication into another. Okay, my grandma was an interpreter. That's pretty cool. That is pretty cool. So obviously, we're not interested. Well, we are kind of interested in what real-world interpreters are, but specifically, we're interested in interpreters in terms of programming languages. So here's some notes for you. A programming interpreter. It does the same thing, okay? But what it's doing is, instead of listening to, I don't know, English and translating it into Polish for someone else, what it's doing is it's reading the instructions that we have typed in, the programming language instructions that we have typed in, okay, and it's translating those things into code that the computer understands, ones and zeros, binary, which is then executed. And it does it line by line. Now, you guys are familiar with this, right? You will have programs that run up to a certain point and then they stop and you get a trace back, okay? It runs the program up to the point where it doesn't understand, okay? And it halts execution when it encounters an error. Okay, so some examples of interpreted languages. Python obviously is the one that you're going to be most familiar with, but some of you might have used Lua. You might have used JavaScript if you've been editing web pages, stuff like that. Bash if you've written scripts for the Linux command line. Visual Basic if you hate yourself. So what I'd like you to do, while I just go and grab myself a drink, have a quick discussion, either in the chat here or on the on the Discord. What do you think some of the advantages and disadvantages of this sort of translation are? So that idea of running your code until it hits an error and then stopping. What's the advantages and what are the disadvantages of that? Okay, and I'll be back in one moment. Here, do you want some music while you discuss this? How about this? This one's called Captain Scurvy. Right. Right, so anyone got any suggestions of advantages or disadvantages of this approach? This line by line, start at the top, keep on going until you hit an error and then die. Someone hit me with some advantages and disadvantages. I attempted to snap his neck because Owen Butler told me to. You can debug easily. So, yeah, I mean, why? Can someone say why it's easier to debug? Why is it easier to debug using this method? Yeah, because the program stops. Well, let's be careful here. The program doesn't necessarily stop where the error is. The program stops when it reaches something it can't do. The error might be elsewhere, but has a knock-on effect. Okay, but usually, it gives some indication as to where the error might be. Jenny is quite right in pointing out it would be slower because the code has to be translated while the program's running. It is. Interpreted languages are much, much slower than compiled or assembled languages. I mean, and that makes sense, right? Think about like real life translations. You're not going to be able to have a conversation with someone that doesn't speak your language at the same speed using an interpreter than you would be if you both spoke the same language, right? You have to translate. There's always a delay translating those lines. It's a lot slower. The program stops where the error is. Disadvantage. It needs the interpreter to run, and that's an overlooked disadvantage, shall we say? Right? If you write a Python program, that Python program is only going to work on computers that actually have a Python interpreter installed. Now, Linux has Python interpreters mostly installed by default, so if you're running on a Linux system, you don't have to worry about it, right? Windows, you're going to have to install Python. You can't. Well, there are some programs that allow you to create a Python executable, and what they do is they wrap up the Python code in a packaged runtime environment. But the problem there is that one of the big advantages of the interpreted code is that you can write the code once and it will work on any platform. So why does every stream degrade into shitting on Windows and promoting Linux and Bitdefender? I'm not saying that Windows is bad because it doesn't have Python installed. If you think, oh man, it doesn't have Python installed, that sucks, then that says more about your opinions on Windows than mine. Also, I don't run Bitdefender on Linux because don't have to, cause there's no viruses. Just saying. Okay. That's why Scarp. I don't know what that means. Better and worse, it depends what you're using the system for. But we're not going to get into a comparison of operating systems. That's a different unit. Don't worry, we'll get there. There are a number of different advantages and disadvantages. Okay, let me explain what these things mean. Okay, you'll be able to note these down. As you guys have pointed out, it is easier to locate errors because when the program dies, you kind of know what it is that's caused it. You can see how much of it worked beforehand. Okay, if the program doesn't even run at all because everything needs to work before you run it, you can't even investigate the working bits. It's platform independent, right? What I mean by platform independent is generally with an interpreted language, you write the code and it should work on any platform as long as the interpreter is installed on that machine. Dynamic typing, dynamic scoping. What the hell does that mean, Smith? Dynamic typing, in Python, if you declare a variable, you can say name equals Bob, or you could say age equals 12, or you could say happy equals false, or something like that, right? The data type is determined by the data that is provided, and also that data, each variable can shift to different types of data. Okay, you could say happy equals false to start off with, and then you could say happy equals 10. Well, that's two different data types. If I say happy equals false, what is the data type? Yeah, it's Boolean. And if I say happy equals 10, what does the data type then change to? Changes to an integer. Now, in other programming languages, usually compiled programming languages, you have to specifically say what type of data a variable is going to hold at the time when you write the program. Okay, so you say age has to be an integer, and it's never ever going to be anything other than an integer. That's what it is. It's an integer. You try and do something with it which is not integer related, and you'll get an error message. Okay, so dynamic typing means you can change the data type to various different things. Just to address something that George, a falsehood that George spoke here, C++ is better than Python. It all depends what you are using the language for. If we're talking about dynamic AI scripting, I would say that Python is going to be a better solution than C++. So it's it all depends what you're using it for. Okay, I've put down here as well more free ? Usually, if you're writing a program in an interpreted language, when you distribute the code, you're literally distributing the code, and then people can wade in, they can edit the code to whatever it is they like, and they can change parts of it. Okay, so they can see your program and they can say, yeah, wouldn't it be better if it did this? And then they can edit it. Okay, it gives the user more freedom to shape the program to what they want, which I personally think is a good thing. People who are out to make money and see their code as a trade secret would probably disagree with me, but really, who cares about those people? Not me. So yeah, more free. I don't mean free as in beer, I mean free as in speech there. So disadvantages, as we've pointed out, it is a lot slower because it has to translate everything as it goes along. Vulnerable to code injection. Now, when I said more free, and I said that was a good thing, it does come with a bit of a caveat here, in that if anyone can see the code, it means that anyone can edit the code and potentially cause the code to do some nasty things. And that's not so much an issue if it's a standalone program running on your home computer, but if it's an interpreted language like JavaScript, which is running on the internet, you can do some fairly nasty things with it. And yes, if it's interacting with a database, then you could potentially corrupt said database, install 40 terabytes of Alvin and the Chipmunk films. I mean, if you can, yeah, sure. That's so yeah. And also, yes, as George has mentioned, fork bombs. For those of you that don't know, a fork bomb is a program which essentially it's a primitive worm. Really, what it does is it will spawn two copies of itself, which then run in the background, and each of those copies will spawn two copies of themselves, which run in the background, and so on and so forth until all of your memory has been used up. Generally not a good thing. And fork bombs will here you go. Here's some Linux Windows similarities here. They're fork bombs that will eat up your system resources on Linux as well as on Windows. So there you Okay. Requires the interpreter to be installed on the machine. I've mentioned this briefly, but when you write a Python program, in order to run that Python program, you need to have Python installed. If you've written a Lua program, you need to have a Lua interpreter installed, and so on and so forth. Okay. You can, in theory, write code which will then get wrapped up in a runtime environment which can then run on the desired system. But the problem there, if you do that, it means that your code is no longer platform independent because that executable will only work on a single system. Okay? Does all of this make sense to everybody? Yes, yes. Right, does anyone have any questions about interpreted languages? Is that yes, you do have a question, or yes, you get it and you don't have a question? Is that making sense? My old German teacher, Herr Sommer, he always used to say, "Is that intelligible?" Was it intelligible? Yep, I guess it was intelligible. What's that thing you do in French where everyone just yells out words in French over and over and over again? I hear that all the time, man. Um, Can you easily find the source code of a program written in interpreted languages? Yeah, yeah. Because usually the files you get are the source code. They don't get transformed. Okay, because remember it's being translated as you run it, which means it doesn't get changed into bytecode first. So if you have Lua programs, in fact, I can show you right now. Let's just go to see if I can get this on the screen for y'all. This is the code which basically makes my operating system window manager do what it does. I edit it to put specific commands in, and the code sits there and it's run by my operating system as and when it needs to be run. Okay, it's not like a separate program which is run. It's there. It is there. So usually. If you have programs that use Lua or Python or whatever, the files will be there on the system. So I mean, you can do a search. You can do a search for star.py, star.lua. In fact, in your Python install, you'll find that most of the code that makes Python work is written in Python itself. So you can have a look at how Python does Python. Some of it is in C. But there's nothing stopping you from editing those Python files and completely ruining your entire install because you don't know what you're doing. So there you go. Anything else? Any other questions about this? What programming language are interpreters written in? It depends. I've seen Python interpreters written in Python. Maybe not the speediest thing ever. It all depends. I mean, on a base level. For speed reasons, you'll find that the fastest ones are usually written in assembly language because that's closest to what the computer actually understands. But idle, if you've used idle to program in Python, I think the whole of idle was written in Python. So yeah, there's that. You got it. Mind you, having said that, idle is just the IDE, the actual interpreter itself. I think the actual interpreter itself is a combination of Python and C. So I mean, I think it's usually a low-level language, or a high-level language that can do low-level access. So assembly language C. Something similar to that is probably going to be a thing, but don't quote me on that. I mean, that's some extra research that you can do. Okay. Cool. Now then, the next slide says this: complete the first section of the worksheet. Now, the first section of the worksheet is just a question, right? And it's done sort of like a short form essay question. And when I say essay, I don't mean like loads of pages. Okay, I mean like a 6-mark essay question that you might see on an exam. So we're looking at maybe half a page of handwritten text, so a couple of paragraphs, right? The question is, write a detailed explanation in your own words and using suitable examples of a programming interpreter. You should explain the relative advantages and disadvantages and structure it in the same way as an essay question on an exam. Okay, so I can't post that in the chat. I'll stick it in Discord. Okay, but really, I'm not after tons of work here. I think the original plan was me to explain this, and then you'd have the rest of the lesson to work on that, and then we'd explain the next bit. You have the rest of the lesson to work on that bit. Don't know how well that translates to online learning, but do you think, based on what I have explained to you today, do you think you have enough information about interpreters to give me a decent answer to that question, like explain in detail what a programming interpreter is? And it's all right to say, yeah, I mean, probably. Okay, that's cool. You might have to do a little bit of extra research. You know, you might have to go and there's nothing wrong with going on the internet, having a look, maybe finding some other videos of people that maybe explain it a little bit better than me, or going on Wikipedia. Okay, it's not a task that I expect you to instantly say, yes, I can do that. Okay. But if necessary, you might have to do that little bit of extra work. So, I mean, on a just to summarize, an interpreter is the thing that takes what we have written, takes the Python as an example or the language, and it translates it line by line into a language that the computer understands. Okay. That's basically what it is. You need to find a way of explaining that with maybe a little bit of a technical explanation in there, and give some examples of the advantages and the disadvantages here. You might want to do some research, find out what this platform independence actually means, give some examples of dynamic typing. I didn't even mention dynamic scoping. So that's something that maybe you can investigate. Okay, I'm trying to encourage your independent research skills here. Okay, so like I say, I'm not after an entire essay here, just a detailed answer. But this is more for you than it is for me. Okay, the more you find out about this, the more research that you do into finding this out, the more stuff you can get in your notes, the deeper an understanding you will have, and then you will be able to do better in your any questions that ask you about this. I'm just seeing if there is a I'm trying to find a reasonably easy to understand page on dynamic scoping. Blah 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 blah. Is that something that you guys are going to be able to understand, or so? Yeah, that's maybe a little bit technical. Ignore the thing about scoping for now. What I'll do is I'll create a little document that explains it a little bit better. It's basically you know, when you declare a variable inside a function and you can't access it outside that function, it's all related to that. But for now, don't worry too much about it. I'll get you a thing together. Alex, stop posting fork bombs in the chat. Thank you very much. Okay, right. If we're all happy with that, I will post the question in the what I'll do actually is I'll just share up the worksheet in the Google Classroom, because then you can see all of the questions that are coming up as well, and you can prepare for those. Does that sound fair? Is that good? Are you all reasonably happy and excited to be back learning this new unit of computer science? So just indeed it does. Good. Define happy. I'm unable to do that. Don't know what it means. Post crab emojis though, because I quite like those crab emojis. Cool. That's it. Happy to have had you all here today. Thank you very much for tuning in. I love you all.